Hello friends, welcome to bispsolutions.com. My name is Sumit and I'm a business analyst with BISP Solutions. And today I'm going to cover a new topic in Python machine learning. And the topic for today's video is hierarchical clustering. And within hierarchical clustering, we would be going to talk about agglomerative clustering. Is basically it's an approach to clustering that build hierarchies of clusters in two main approaches. So basically clustering is grouping of points into various clusters into various groups, and there are two main approaches of clustering, hierarchical clustering. First is agglomerative clustering and second one is divisive clustering. In agglomerative clustering, it's a bottom-up strategy where each observation starts in their own clusters and it pairs to the nearest cluster, then it forms a pair of a cluster and then it merge upwards in the hierarchy, and at the end we left only with one cluster. Whereas in divisive clustering, it's a top down strategy where all observation starts out in the same clusters and then the clusters are splitting recursively downwards in the hierarchy. So they are opposite of each other. And the most commonly used clustering in industry is agglomerative clustering. So bottom up strategy is very helpful to create clusters and to place the clusters using Python in the form of charts. So therefore, in this video, we'll be going to talk about agglomerative clustering. Now, what exactly agglomerative clustering is? The idea behind is to ensure the nearest points in the same clusters or nearest point end up in the same clusters. So it starts with a collection of C of collections of clusters of C of n single tone clusters, and where each cluster contain one data point. So one data we would be consider as 1 point, and we used to mark it as 6 ci is equal to xi. So one cluster, so we'll be assuming that one cluster contains one data point. So if we have n number of data points, we can have n number of clusters. So during working on clustering, we need to specify the number of clusters, and it continuously keeps on repeating until only one cluster is left. So let's assume that we start with 5 data points. So the two nearest data points will form one cluster. Then remaining two data points forms one cluster, and then it combines into a common cluster into a single cluster. So this process keeps on repeating until only one cluster is left. So we need to find a pair of cluster that is closest to the minimum of the, that is ci, or it's a pair of a cluster which is nearest to the pair of the clusters. Then we merge the clusters into a new clusters and we used to call it as ci plus j, and we remove the Cij from the collections, and we add this cluster. So basically we remove the existing one nodes and we add the combined cluster or the merged cluster into that collection. So either we can use a scatter plot to describe or to demonstrate the clusters, or we can use a dendrogram. So dendrogram is the most appropriate chart which can be used to show the hierarchical trees of clusters. So basically it represents the clusters in the form of hierarchical trees, and we need to define a distance metric over cluster. So we used to call it as Euclidean distance. So let's take an example and let me demonstrate you that how can we create agglomerative clustering in Python and how can we place the same using Dendrogram. So let me create one Python GUI app, And here the very first line I'm going to write is I'm going to import some libraries. So sklearn import cluster comma datasets. Let me save this and test123.py, and it's perfectly fine. And the data which I'm going to use this in, I'm going to use the data set for this example is that's the iris data, which has got sepal length, sepal width, petal width, and the species. So I'm going to use the sepal length and sepal width, and going to place the same using dendrogram and agglomerative clustering. So let's import matplotlib dot pyplot as plt. Then I'm importing cborn as SNS. I write iris is equal to dataset dot load underscore iris. So first of all, I will be loading this iris dataset into Python, and it will get stored into iris variable. Then I'm importing scipy dot cluster dot hierarchy as sch from sklearn dot cluster, and will import, I would be importing agglomerative clustering. So agglomerative clustering, and let me test this much first. Any error? There's no error, so it's executes perfectly fine. Now, as I mentioned that we would be performing the clustering only on two values, the sepal length and sepal width. So for that, I create a variable called x is equal to iris dot data, and I would be extracting the values of first two columns, that is the sepal length in centimeters and sepal width in centimeters, and y underscore iris is equal to iris dot target. And if I simple print x, sorry, so I got the value of iris. So that's the iris data which gets extracted into x. So you can see sepal length and sepal width, and this is in the form of array. And now we are going to create agglomerative clustering and plot this using a scatter plot chart. So I'll create C is equal to clustering, and I would be defining the number of clusters. So n underscore clusters is equal to, I want two clusters, comma, affinity is equal to Euclidean distance. So Euclidean, comma, linkage is equal to WOD. WOD basically it's an approach from bottom to up. So I'll just test it, and executes perfectly fine. And now if I simple plot this on a scatter plot, so before going into that I write y, because while we would be plotting into scatter plot we need x and y both. So hc is equal to hc dot fit underscore predict of x. And now finally I want to plot this using a scatter plot chart. So the plotting will be x y under y underscore hc equal 0 comma 0, and I would be plotting all the clusters. So basically we were creating two clusters and we would be plotting all the values of clusters in same chart. Instead of placing them into different charts, into multiple charts, I want to add them into, I want to put them into a single chart, into a common chart. So x y underscore hc equal 0 comma 1 comma size is 10, and the color is red, and also I'll add a label is equal to cluster 1, and finally plt dot show. So let's test it. You can see the clusters have been placed, and in algorithmic clustering, first of all, we would be going to find out the nearest clusters, so the two nearest clusters, and we combine them and form into one cluster. So let's assume that this is one cluster. We have, although we have created two clusters, so that's the one cluster I have added. So let me do one thing. First of all, let me add one more cluster, and then we'll try to understand it with another figure. So I'll say PLT, and the value for placing the cluster is, it should be y 1 comma 0 and at 1 comma 1. Size is 10, and the second cluster I want in blue color and call as cluster 2. So we have two clusters now, cluster 1, cluster 2, and in agglomerative clustering, so first of all we find out the nearest cluster. So let's assume that these two clusters are, this is cluster 1, cluster 2, and they are near. So we join them, then we find out the another nearest cluster. So we have a lot of clusters, and it's difficult to find out like this. So there is a solution that we can decrease the size of, so we can decrease the size of the value. So instead of displaying all the values, I want to target only 10 values at a time. So this helps me to understand more into it. Now in this case we have two clusters, so the nearest two clusters are these two clusters, so it forms a dendro, it forms one group. Then the another cluster, another nearest cluster will be, let's assume that this is the nearest cluster to this one. So this, and let's say this one is, so this forms one group, and these two combine and form one cluster. So in same manner, if this process keeps moving on, and at the end it forms a one big cluster, a single cluster. So all of them, they combine into single cluster. Then this is a little far. So, and the height of the dendrogram, the height of the graph depends on the, it depends on the distance between two clusters. That is called Euclidean distance. So that's how we plot this into a scatter plot. Now, if I want to create a if I want to present the same data using a dendrogram, so let me remove this first of all, and make let me put them as, mark them as a comment. So here I write PLT. So I simple write here PLT dot, oh, PLT dot show is already there. So I write here, I'm going to create a dendrogram. Dendrogram is equal to sch dot dendrogram sch dot linkage x comma method is equal to what, so we will be using the same what method, up and top to bottom approach. X is equal to method and double brackets, and finally I simple write plt dot show. When we test it, it creates a, dendrogram. The spelling should be, it's dendro dendrogram. So let's run it again. And you can see a dendrogram chart has been created using based on the clusters. And here, because the size, I removed that size. Earlier it was didn't specify the numbers, so it includes the all the datas. So if I want first 10 or first 20, so let's create uh, a value to 20 and the 20 records, and we have 20 records, and you can see the numbers are not in sequence. And why that's so? Because it automatically find out the nearest two clusters and place them. And also you can see the height between 0 and 17 is very less, 5 and 16 is very less. It means the distance between these two clusters are very less. This indicates the Euclidean distance. And we have, if we find out the clusters, so this is at the end it holds one clusters. And if I draw a line from here, so if I draw a line here, so we have one clusters. And if I draw a line here, so then we have two clusters. And if I draw a line here, so that is, if we wanted to find out the number of clusters, so right now the number of clusters at the end, it creates only single clusters. But if we want to know the number of clusters, so we can count them, and the nodes we can count the headers, and we can find the clusters. And here the approach is bottom up. First of all, the nearest two clusters forms one, nearest two data point forms one cluster. Then it joins with the cluster, the points which is near to it, and it forms the, this is the this, as I mentioned again, the height indicates the, this indicates the distance between two data points. So that's the way how we can create a dendrogram, and how to create an algorithmic clustering with the help of what. So using what technology, and this comes under hierarchical clustering. So one question comes in mind, that what's the business use of this clustering and where are we going to use it? So basically the business use of clustering is that it would be useful in a study to predict the cost impact of deregulation, and to perform the requisite analysis. Economists would be required to build a detailed cost model of the various utilities, and it would save a considerable amount of time and effort by clustering the similar type of utilities, building a detailed cost model for just one typical utilities in each clusters, and then scaling up from these models to estimate the result of all utilities. So that's the business use of clustering. And that's all in this video. I hope you like this video. If that's so, don't forget to press like button. If you have some queries, you can post your comment in comment box. Thanks for watching. Have a nice day.